Hi everyone, this is the video lesson for Unit 3, Notes number 3 in Geometry. In today's lesson we're going to talk about triangle congruence postulates and theorems, and in short, these are the shortcuts to proving triangles congruent. So as of now, in order to say that two triangles are congruent, we'd have to prove all three pairs of sides congruent and all three pairs of corresponding angles congruent. So today we're going to learn 5 methods for proving triangles congruent. Our first method is called side, side, side. Right? If we know that the three sides of one triangle are congruent to the corresponding sides in another triangle, then the triangles are congruent. So if you check out the markings, we have a pair of corresponding sides with 1 tick mark, a pair of corresponding sides with 2 tick marks, and a pair of corresponding sides with 3 tick marks. This picture shows that these two triangles would be congruent by the side, side, side postulate. So we shortcut it and we can write S, S, S when we're stating a reason for our triangles being congruent. Our next postulate is side, angle, side. And this one is very specific, so you have to pay attention to the order of the items that are congruent in your picture. Side, angle, side says if two sides and their included angle, and we'll talk about that in a second, if two sides and their included angle in one triangle are congruent to the corresponding sides and included angle of another triangle, then those triangles are congruent. Okay, so if you take a look at our picture, we notice that we have a pair of congruent sides that are corresponding. We have a second pair of congruent corresponding sides, 2 tick marks there. And then you see this angle in between those two sides. That's what it means to have an included angle. It's the angle that's sandwiched in between your two marked sides. So order, again, is very important. So when you go to write this as a reason on your practice or in a proof, we're going to write side, angle, side. All right, our next theorem involves things in a different order. And in the next theorem, called the angle, side, we have a pair of angles, and then we have a second pair of angles. And then we have what's called the included side. So let's read through this theorem. If two angles and the included side of one triangle are congruent to the corresponding angles and included side of another triangle, then those triangles are congruent. Okay, so this time it's the side that's sandwiched in between the two pairs of congruent angles. So if you check it out, we have angle. I'm going to switch to a pen. Angle, side, angle, congruent to angle, side, angle. So we shortcut this one to be ASA, angle, side, angle. All right, and our fourth method, it's called the angle, side. And again, that speaks to the order in which these items will appear in the picture. It says if two angles and a non-included side, so it can't be the side in between the two angles. So if two angles and a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then those triangles are congruent. So let's check out the positions of all these things. So that's one pair of congruent angles. Here's our second pair, so that's the angle piece. And then look at this side. It's not in between the two pairs of congruent corresponding angles. Right. Our shortcut for writing it would be angle, side, AS. Right, the last one is very specific to right triangles. So I'm just going to scoot this up a little bit. Right. If we know that our two triangles are right triangles, either we're given that information or we see that they have right angles, we can use what's called hypotenuse leg congruence. It says if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then those triangles are congruent. Okay, so just to point out, the hypotenuse is the side that's opposite the right angle. So I've labeled those in blue. A leg is a side of the triangle that helps to form the 90-degree angle. Alright, so if you wanted to come in and label it like H and L, like H for hypotenuse and L for leg, if that helps you identify the pattern, you can do that. So we would say HL, hypotenuse leg. Okay, I'm going to mention briefly two things that do not work to prove triangles congruent. Alright, so one of those two methods is angle, 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 and the other one is side, side, angle. Okay, so whenever we'll give angle, angle, angle as a reason for triangles being congruent, or side, side, angle. With side, side, angle, if you think about it in reverse order, angle, side, side, think about what that spells. It doesn't work unless your triangle is a right triangle. You can see the order here. We would have side, side, angle, congruent to side, side, angle, but this is a special case because it's a right triangle. So even in this case, we don't write side, side, angle. We would write hypotenuse leg. In the case of angle, 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 AAA would create similar triangles, not necessarily congruent triangles. Okay, so watch out for those two methods. All right, before we move on to actually practice this, I want to just give you a little more information about included sides and angles. An included side will touch both of the marked angles. So in here, I'm just going to draw a triangle really quick. And let's say I have two angles that are marked in my picture. All right, the included side would be this side in between them. So I'm just highlighting that in blue. An included angle will touch both of the sides that are marked in your picture. Okay, so if we wanted to say that this is our included angle, that angle would be included in between two marked sides in your picture. So I'm going to mark those with tick marks, like this side and this side. Okay, so this one is the included side, and this one is the included angle. So a non-included side, if we have a picture and we have two angles that are marked congruent to each other, then either this side down here would be a non-included side, or this side right here. Okay, so the blue and the green are each non-included because they are not in between. All right, and each of those sides only touches one of the marked angles. All right, a non-included angle, our last picture here, if we have two sides that are marked, a non-included angle would be an angle that is not in between those two sides. So this would be a non-included angle as an example. Okay, so we have lots of examples to do. I'm going to go through all 12 on this page, and we're going to look at our markings and see if we can identify whether or not the two triangles are congruent. I would suggest using highlighter to highlight congruent pieces in your pictures because it really can help you to identify the patterns. In our first example, I have side AC congruent to DE. So I'm just going to put down a little note that that's a pair of sides that are congruent. Then, if I continue going around the figure, I have an angle A congruent to angle D. So that would give me a pair of angles congruent. And if I keep going, we're going to skip over side AB because it's not marked, and we're going to go over to angle B, which is congruent to angle F. And so if we take a look at that order, I have side, angle, angle, which is also known as angle, side, side, angle, angle, side. So yes, these two triangles are congruent. They're congruent by angle, angle, side, or side, angle, angle. Doesn't matter what order you say it in. And then we're going to write a congruence statement for the two triangles. Use your markings to help you. The first triangle is named in whatever order you choose. I'm going to choose alphabetical, triangle ABC. Now when I name the second triangle, I have to use the markings to help me out. Angle A corresponds to angle D, so the second triangle, its name has to start with D. Angle B corresponds to angle F, so D to F, and then finally to E. So triangle ABC is congruent to triangle DFE by side, angle, angle, or angle, angle, side. By the way, you may want to list your methods at the top here. So those methods are side, 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 angle, side, angle, side, angle, 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 side, or side, angle, angle, and hypotenuse leg. All right, and the next one, again, I'm going to highlight things that are congruent and see if they have a matching pattern. We have angle L congruent to angle K. I have side LA congruent to side KD, and then we have a problem because in the first triangle it's looking like angle, side, angle. In the second triangle it's looking like angle, angle, side. Since the patterns don't match, we have to say no, these are not congruent. Okay, we would need this side to be congruent to that side in order for these two triangles to be congruent. So if you get no as an answer, then you're done. Move on to the next one. Okay, one of the things we're going to talk about a lot is using given information to mark up your diagram, or just noticing things about your pictures that are true. Right. What I noticed in this picture is that these lines are parallel. AB is parallel to DE. And what tells me that is that little arrow right there. I'm just going to make a note that we have parallel lines. Okay, so this is the thing about math. We always tie into something that we've learned previously. So if you recall, we studied parallel lines in Unit 2, and we learned that when two parallel lines are cut by a transversal, which that blue line is going to be my transversal, we create alternate interior angles that are congruent. Right. We also have another transversal going the other way. I'm going to highlight it in a different color. And that would give us angle A over here congruent to angle E. Okay. And now if you notice, we also have congruent segments in here. So I've got angle, angle, side, congruent to angle, angle, side. So yes, these two triangles are congruent by angle, angle, side. Okay, with the naming of them, be really careful and use your markings to help you. Like angle A, start it off, go to B, into C, and then that's going to be congruent to. Now, since I started with angle A that has two arcs, start with angle E with two arcs. Then go to angle D, and then into C. Order matters when you're writing a congruent statement. All right, in the try it problems, we're going to mark some congruent things. Okay, first of all, what I noticed in this first problem is that we have a right angle. So I'm also going to mark the angle next to it as a 90-degree angle. Okay. When triangles are back to back like this, we can use the reflexive property to mark that shared segment equal to itself. Right, you might be tempted to say angle, side, side, but we don't have an ASS postulate, remember that. Since these are right triangles, we are going to use hypotenuse, leg. So this is yes, hypotenuse, leg, and we can name it triangle ABC, congruent to triangle, and notice I went from A to B and then down to C. I'm going to go D to B, and down to C. All right, shared information or shared sides are common again in this next question. Mark that segment congruent to itself by the reflexive property, okay? And then check out your order. We've got angle, angle, side, congruent to, angle, angle, side. All right, be really careful, okay? These two are not congruent to each other because notice that this side is coming out of the angle marked with 2 arcs. That's not the right side that we need. That's not the correct side that we need in order to say these two triangles are congruent. All right, so the pieces are not in the right places. So we have to say, no, these two are not congruent to each other. All right, a common mistake in this third one is that people want to use hypotenuse leg because they're right triangles, right? We are just going to use side, angle, side for this one. This side, that's a leg, is congruent to this side, which is also a leg. The angles are congruent because they're both 90-degree angles. And then we have another pair of sides that are congruent, and those are also legs. So these two triangles are congruent, and it's side, angle, side, not hypotenuse leg, because this is a hypotenuse, and it's not marked congruent to this hypotenuse. Okay, so the triangles are still congruent, it's just not hypotenuse leg. So a way to name those congruent triangles could be triangle ABC, congruent to triangle ZYX. Again, I went from A to B along the segment with 1 tick mark towards the right angle. Follow that order with the second one. All right, this one is not drawn to scale, meaning something happened when the picture was transported here. These two triangles actually are congruent by side, angle, side. They just don't appear to be congruent. So we're going with the markings and not by what they look like, side, angle, side. And I know that's a little bit confusing, but sometimes that happens with our pictures. All right, triangle BEG is how I'm choosing to name the first one. So once I pick a name for that first one, the second one, I have to follow that order. So I went from B to E along that segment with 1 tick mark. So in the second triangle, I have to go F, X to F to R. All right, in our next one, these two are not congruent to each other, and I'll show you how I know really quickly here. I see that this angle and this angle are congruent, but I see in the first triangle that that angle is anchoring the segment with 2 tick marks. In the second triangle, that angle is anchoring the segment with 1 tick mark. So these two triangles are not congruent to each other. Okay. It would be angle, side, side anyway. So we don't have side, side, angle, or angle, side, side as a congruence postulate. All right, another one that's not drawn to scale is this guy, the last one in this row. All right, if you notice, in the first picture, we have one side with 1 tick mark. It's marked congruent to that side in the second triangle. They just don't appear to be congruent. We have a side with 2 tick marks, and then we have a side with 3 tick marks. So all 3 sides of the first triangle are congruent to all 3 sides in the second triangle. So that's an example of the side, side, side congruence postulate. All right, be careful when you name it. All right, again, when you name that first triangle, just go with whatever order you choose. I'm going to go with MBY just because it seems to make sense to go that way. Now, notice that I started at M, which is in between the side with 1 tick mark and the side with 2 tick marks. Angle M corresponds to angle Z because that's in between the side with 1 tick mark and the side with 2 tick marks. And I went along the side with 1 tick mark, so you're going to do the same thing. So this is going to be congruent to triangle Z, Q, All right, we're on to the final three, and check out the similarities between these pictures. Okay, first of all, I notice that in all three of these pictures, they share a side. So I'm going to come in and mark it congruent to itself, okay? In the second picture, I had to use 2 tick marks because 1 tick mark was already taken. All right. In this first picture, they are right triangles. So potentially we could be using hypotenuse leg. It is true that they are sharing a hypotenuse, right? But we don't have any indication that the legs are congruent to each other. So we have to make the conclusion that no, they're not congruent. They appear to be congruent, but we can't say for sure that they are without another piece of given information. All right, in the second picture, what we have here again is the hypotenuse. So yeah, the hypotenuse is congruent to itself, like from each triangle. And then we actually have legs that are congruent. This leg is congruent to this leg. So that's a leg, that's a leg. So these two are congruent by hypotenuse leg. So we had the first case, they're right triangles, but they're not congruent. In this case, they're right triangles, and they are congruent by hypotenuse leg. Okay, when you go to name them, just be careful. If I name this first triangle A, B, C, that means I have to name the second triangle C, D, A. Again, I went along the unmarked side here towards the right angle. So go along the right, the unmarked side on the right here towards the right angle. All right, last one. These are right triangles because we do have right angles. They share a hypotenuse. Okay, so that is a side that's congruent from one triangle to the next. But notice in this case, I'm indicating that the lines are parallel to each other. Parallel lines are not necessarily congruent, but parallel lines do give us alternate interior angles that are congruent. So this is a little bit of a tricky one because it is right triangles, but we are going to have angle, angle, side. And again, that's congruent to angle, angle, side in the other triangle. So yes, they're congruent. The reason is angle, angle, side. I'm going to name this triangle on the left triangle NTG, and it's going to be congruent to triangle GMN. All right, that's it for our practice together. So if you give the practice and the learning check a try, then I can give you some feedback. If you would like to meet with me for extra help, just let me know and we'll set something up.